12 minus 4x. That is the first thing we have to do. Then the next thing is to divide both sides by 3 so as to make the coefficient of our y equal to 1. So by so doing, 3y divided by 3 less than 12 divided by 3 minus 4x divided by 3. So this cancels this. Y is less than 3 in 12, that is 4, minus 4 over 3x. The next thing to do here is to consider our coordinates. But before we consider the coordinates, we must consider the borderline. The borderline here, or the boundary line. Let me use boundary line. The boundary line. The boundary line here will be y equal to 4 minus 4 over 3x. Then, having done this, so let's consider the coordinates. When y is equal to 0, then our x will be 4 over 3x equal to 4. Because you are transferring, this one is 0, then you transfer it to the other side, it becomes positive. So here, we cross multiply. If you cross multiply, you have 4x equal to 3 times 4. And 4x now will be equals to 12. Dividing both sides by 4. When we divide both sides by 4, we are going to have 3. Then x will be equals to 3. So the first coordinate is 3, 0. That's our first coordinate. Then the second coordinate, that's when our x, when x is equal to 0. So when x is equal to 0, we substitute value of x into this boundary line. And if we do that, we have y equal to 4 minus 4 over 3 into 0. Then we have y equals to 4, because this 0 affects this and turns it to 0. 4 minus 0 gives 4. So automatically the second coordinate will be 0, 4. And since we have our coordinates, then we can now go ahead to sketch the graph. This is our x-axis, this is our y-axis. This is the point of origin. This is the point of origin. So we try to locate those coordinates, those points here. The first one is when x is 3, y is equal to 0. So we know that if this is our origin, 1 will definitely be here, 2 will definitely be here, 3 will definitely be here. And along the y-axis too, 1, 2, 3. Then, since when x is 3, y is 0, when x is 3, y is 0, so automatically the point will be here. Then when x is 0, y is 4. So automatically that means we have to extend this to a point where we have 4. Let's say this point. This is the point. Then we try to connote our boundary line with a broken line. So we connote our boundary line with a broken line this way. To start from the y-axis and cut the x-axis at that point where y is 0, x is 3. So this is the point. It goes on and on. Then we have also our x is greater than 0. So x is equal to 0 is on this line. We are having that y is greater than or equals to 0. Okay, x is equal to 0, we have it on this line. We have x is equal to 0 on this line. Sorry. Then we have our y is equal to 0, we have it on this line. That's the boundary line. So then that means the equation, then this one will be the shaded region. Let's say this region is shaded. This region is shaded. So if we are to solve this inequality graph simultaneously and solve for our values, at this point where our x is 1, y is 0. So we can consider that point, x1, 0. Then we can also consider this point when x is 1, y is also 1. Then we can consider this point when x is 2, when x is 2, y is 0. Then we can also consider when x is 2, y is 1. Y is 1. This point. So here we're having 4 points. So these ones are the solution of this graph, where this point is y equal to 4 minus 4 over 3 x, and that is our boundary line. So this is the solutions of the graph. Algebraic fractions. Algebraic fractions are simply the simplification of fractions, dealing with the factorization of fractions into their lowest terms. And when we consider this, we talk about the numerator and the denominator. Examples to justify this claim: simplify and reduce to the lowest terms where appropriate the 3 questions in figure 1.1a below. So these are the questions designed for this figure 1.1a. We have the first question, which is this, the second and the third. So the question, we are to simplify and reduce to the lowest terms where appropriate. Here, let's consider the first question, which is this. This is the first question. If you look at this question very well, this is a typical example of an algebraic fraction. So if you look at this, we discover that m is common to this first term and the second term. U square is common to this and this. And if you look at 6 and 4, you discover that 2 is a factor of both numbers. So automatically, I can say 2 is common to them, m is common to them, then u square is common to them. So I want to factorize 2m u square out of each one of them. And by so doing, I'll have 2m u square from this. Then I'll be left with 3m u. Then on this other side, when you have a minus a, then if I move 2 from here, if I factorize 2 from here, I'll be left with 2. If I factorize m from there, there will be no m any longer. Then if I factorize u square out of this, then I'll be left with u. I'll be left with u. Then I can close this. And so I have settled the numerator. Let me move to the denominator. In the denominator case, I realize that I have this. I can break this to, let's say, m is common, then u is also common. So if I bring mu out of this, then I will have m is common to this, then I'll have 9m squared. Here, mu out of this, I will have 9m squared. Then mu out of this, I will have minus 4u squared. So that is what I will have. So if you look at this very well, you discover that I can rewrite this such that it will look at something that is very unique. So you have 3mu minus 2u. This is the numerator. The denominator, I can write this as mu. Let this one be in a complex, out of the complex bracket. Then I can write this as 3 squared, which make up for 9, m squared. Then this one is minus, I can write this one as 2 squared, which make up for 4, then u squared. So I'm still in line. Then if you look at this very well, I can decide to say 2mu squared, 3mu minus 2u. Then here, I can decide to say mu out of the complex bracket. Then I have 3m all squared. Since square is dominant, so I can bring that square out and bring the two terms as an entity. Then I can also do the same here too, which is 2u as an entity, then square. And I close it with a complex bracket like this. So automatically, I am still in line. I have not committed any mathematical blunder. So by so doing, we can recall what we call difference. We can recall what is called difference of two squares. Difference of two squares, which states that when we have a particular square and we are taking the negative of the other square, which is known as the difference of two squares, the rule states